Yeah. So if you check the assignment specification, by right, you should send your first part, your soft copy. Send me the PDF by the end of this week 7, which is around this that 7 or 8 of August. Actually, last week I said I informed I think to every group. I said I let one more submission before the final submission. So I think most of you did that part, and I already give mark to your each of your part in your assignment. But since I changed my mind, since actually last week we have a meeting. But long story short, I found out that a meeting with TAR staff, everyone like academic staff, like literally everyone. So during the meeting, I heard that there are some students who get um, below the CGPA, not from our faculty, maybe from different faculty, got 2.5 below, CGPA 2.5 below. So maybe some of them didn't grad on time, so maybe they need to extend, I'm not sure. So in order, or I don't want any of my student in my class fail, or yeah, at least for my subject, I didn't want any of you to fail my subject. So what I can do for you guys is to help you guys to score or to get full mark for your assignment. So for those who didn't get full mark, because you can see your current mark in the last page of your assignment, you can check your mark. So whoever didn't score or didn't get full mark for your part, you still can send me submission. It's up to you guys actually. It's up to you if you want me to check before your final submission. I will check for you guys, but make sure you guys notify me, because if not, I won't go to your link and check your work again. So if you want me to check before your final submission for you guys to get your full mark, so you guys can do so before your final submission, which is 8th of August. So after 8th of August, I won't accept any more correction or any more enhancement on your assignment. Okay, but I think most of you already send or submit and get marks for your part. So you can, to those who didn't get full mark, you guys still have 1 week to correct your assignment before your final submission. At least you guys, all of you can get full mark to carry for your, I mean, you get your full mark for your assignment. Yeah, because you have exam. Exam, I cannot help you much because I don't even have, I don't even know what the question will be asked. I don't have any hint to drop for you guys. So this is the least I can do is by helping you to get full mark with your assignment. Okay. Yeah, I think I make you guys understand, right? That part as tutorial, maybe same as tutorial. What is, oh, you mean the exam question? I think, yeah, maybe yeah, I agree with you. Yeah, I agree with you, Kelvin Shak. I agree with you. Actually, I think I agree with you because I think the question is more or less the same with your tutorial. Hmm. Yes. Yeah, you guys are correct on that part. So I think you guys know what to expect. Maybe you just need to do your tutorial. But I think if you guys do your assignment too, because in your assignment, I think that conclude everything that we covered in our lecture. So if you really do your assignment, you know how to use the notation on, or you know what is the diagram, I think you shouldn't have major problem with your assignment. Okay. This one I didn't change anything, nothing much I changed on this part except this one. I just update this one because I forgot to update last time. So your exam will cover from chapter 1 to chapter 12 on your exam. I think only this one I update already. I edit. And then this one, nothing much, just the same like before. Actually, if you already see your part two, if you already go through your assignment, I mean the specification of your assignment, part two is actually, I won't say less, but actually it's less maybe, but yeah, for part two, I think it's a bit uh in terms of the diagram. I mean, it's a bit complex, not hard, but it's a bit complex compared to your part one. So if you guys already checked your part two, I think you guys know what to expect already. So part one, you need to submit me the PDF by end of this week. Okay, so before we move to our tutorial, before we move to our lecture, any question? I think no. Okay, so let's move to our lecture. So this week is already week 7, and we should cover chapter 6, which is should be covered last week, but I didn't touch this chapter last week because actually last week I already checked this lecture. I already checked this lecture, so I don't want to confuse you guys because this object interaction is, if you guys already see the patch, there's 91 patch, but it is actually only a few diagram. But because the explanation is, there's a lot of explanation in this chapter, that's why it have 91 patch, but it is actually only few diagram. So we will start to cover chapter 6 this week. So this week, chapter 6 is interaction diagram. This one I add myself, if you notice in your lecture note. So before we go to this chapter, let me explain to you a bit what is interaction diagram. So interaction diagram is actually used to visualize the interaction behavior of the system. I mean, for example, what is the interaction, or interaction behavior between the object or maybe the class of the system. That one we will see later. So this chapter is divided or split into two parts, which is part A and part B. So the first one is sequence, collaboration, or communication diagram, and the second part is this part. Okay. So what? So in this chapter, you will learn how to develop your object interaction, how to model object interaction using an interaction sequence diagram. This one is the first diagram that we will learn, and how to cross-check between interaction diagram and class diagram. So this one for the first part. And then for the second part, maybe next week, is how to model interaction using interaction overview diagram, how to model interaction using this diagram, and how to use timing diagram. Okay. Okay. So as an introduction, I think most of you are familiar already with object messaging because this one already, I remember this one should be in maybe first chapter or second chapter. Anyone remember what is object messaging? What is object messaging in our first or second chapter? Okay, let me explain. Let me recap for you guys. Object messaging is actually a way to communicate between the class or an object. So object messaging is the way that they use to communicate. So how they are going to communicate is by sending the message. So they are using message to communicate, which is known as object messaging. Okay, so So let me repeat. So object messaging is actually a method or a way for the object or the class to communicate by each other by sending message. So this is an example of how the class is communicate and the message. For example, this is a class or an object, campaign and an advert. So this is an object or this is a this is an object. So this is an object. It can be a class too, but this is an object. So this is the message which is get cost. So this is the message that they want to send to this object. So this is the sample of, or this is the example of the object messaging. That means this object to this object, they're sending this message. So this is the syntax or maybe example how to write the communication between the object and also the message. Okay, this one is quite simple, but what you need to know is what is object messaging. Yeah, what is object messaging? If you understand or if you can capture the meaning of object messaging, then you guys can understand this part easier. Okay, so this is another introduction, the resilience of design. So if you see here, there's a resilience system. So resilience system is actually how tough or the, for example, if you want to change anything on the requirement or we want to cater any change to the system, resilience of the design is how tough or what's the term? The withstand, yeah, the withstand of the system to the change, to the major distract, withstand of the system on the change. For example, here, okay, there are two different example here. First, the requirement, and then this is the application. So this requirement can cater this application. That means the whole system didn't like affect on the requirement. That means if you change one small requirement or maybe one module, then your system can still working fine. Because when you're in a system, sometimes when we're changing or we do some enhancement or we do something to the system, it will affect the whole system. So a good resilient system is actually when you change something, it doesn't really affect the major function of your system. So if you see on this, on the second second one, second example here, this is not a resilient system. Why? Because the small or, I mean, there are only small part of changing or small requirement that need to be done, but it affect the whole, not the whole application. It affect or give major effect on the application with which cater the requirement. That means once we cater this requirement into this application, it affect the application. So this is not a resilient system. So again, resilient system is actually a system that can withstand ability to any major change of your requirement. Okay. So this is just an example, resilience of design, the process of design. Actually, if you already see or if you already open this lecture note, actually there are many explanation, but actually this is literally about one diagram until page 45. So let's go to them one by one. So a collaboration is a group of objects or classes that work together to provide an element of functionality or behavior. So to provide a functionality or behavior of our system or to fulfill our requirement, to fulfill our requirement, the we need to do a collaboration between our group object and classes because it's very normal in our, it's not in our, I mean it's very normal in any system or any application. You need to use, or you need to collaborate between your group and your classes. Even in your assignment part 1, 2, if you notice there's collaboration, which is the association between different classes. If you remember your diagram, then you know what is collaboration. So collaboration is like an association or relation between a group or classes. So an interaction define the message passing between lifeline. So like I said, we already covered in chapter 1 or chapter 2. I don't remember, but yeah, I'm pretty sure we already covered this is what is object messaging or message passing. So but for this part is new because last time we didn't touch on the interaction between the class or the object. We just go, or we just touch on what is object messaging. So the object, I mean the message that we send, the not we, the message the object send or the class send to one another is defined by the interaction, or what interact, yeah, by the interaction. Like I mentioned just now, interaction can be the interaction can be to provide the functionality or the behavior of your system. So to conclude this point, actually it is a relationship or the message that we send for a collaboration between the group of object or classes to define, no, the interaction define the message. That means our message, the message sent is defined by the interaction. So next, here are the interaction can be modeled using various notation. So here, what is this chapter about? This is the four diagram that we will see in this whole lecture. First one is interaction sequence, communication, interaction overview, and timing diagram. So this chapter is literally about these four diagram, but it's split into two parts, like I said just now. So the first one is interaction sequence diagram. This is the example of interaction. This is the example of interaction sequence diagram. This is new to you guys, but we will see what is, or how to visualize, or how to draw this diagram using the correct notation. So like I said just now, mm, no, I haven't said this part. Sequence diagram. Wait. Okay, actually sequence diagram is actually to show the process. I mean how the communication or the interaction between this object, this is what we call as an, right, this is what we call as an object, oh wait, this is what we call as an lifeline. Lifeline what lifeline, this is only known as lifeline. So this is a lifeline. So this sequence diagram is actually to illustrate or to visualize what is the, what is the association, or what is the message between this object, and this is what we call as lifeline. So this sequence diagram is actually to visualize what is the message, or what is the expected function or behavior that should be done. For example, here, like this is a message. We will go through this notation later, but this is actually a sequence diagram. So from this object register to this object cell, this is the message sent by this register to this cell object. Okay, so every single notation here, uh, they have their own function. Okay, but basically this is your sequence diagram. This is how it look like. Okay, this is new to you guys, but it's okay. Like I said, most of this chapter, or there are a lot of explanation on this chapter. So, like I said just now, sequence diagram is to show the interaction between lifelines. So, this is the lifeline. This is lifeline, register is lifeline, cell is lifeline. So, what is the interaction between these two objects? So, that is sequence diagram. Okay, so this is the basic concept of sequence diagram to show the interaction between object. It can be class too. It's not limited to object. It can be class. So it arranged in a time sequence. So let me explain this one first. So in a time sequence, for example, mm, okay, the time sequence, for example, from this one to this one, this is the first message that they send from this class, from this object to this object. This is the first message that it sent. And then in the next process, for the same application, from this object, they send this message. This is actually a written message. You guys will see later. This is actually a written message. But my point here is in a in a time sequence, that means this message is sent first before this message. So this one, I just conclude myself that the higher the position, that means that first or that process is do first, not do first. They execute or they send the message first. The lower, but as you go down to your diagram, that means it is in the next process. So this one is the first process, and then the last one, this is the last process in your sequence diagram. Do you guys understand what I'm trying to say? Do you guys that part I said just now? Mm, I take it as yes. So yeah, actually, arranged in a time sequence. That means this one should be the first one, and then the bottom one will be the last one. Okay, we will see that one later. So it can be drawn at different level of detail and to meet different purpose at several stages in development life cycle. So like I said, they have lifeline, so it can be at different level of detail and typically used to represent the detailed object interaction that occur for one use case for one operation. This one is just an example. I have a video to show you guys later how to use this sequence or how to draw this sequence diagram. So like I said just now, this one, the one that I mean, this is what I meant just now. Vertical dimension shows time. That's mean this one is the first, your first class 1 minute. Sorry guys. So let's proceed. So this is what I meant just now by vertical. That's mean the first process or the first activity should be on the first higher level of your diagram, and the last or the latest activity or process will be on the bottom of your sequence diagram. Okay, so object or subsystem or other connectable object involved in interaction appear horizontally across the patch and are represented by lifeline. This is what I call, or this is what I mentioned as lifeline just now. The object, your object or your class that this one is lifeline. It can be an object or life. It can be object or class. And then message are shown by solid horizontal arrow. So this is a message. This is a solid horizontal arrow. And then the execution activation of an operation is shown by a rectangle on the relevant lifeline. Execution or activation, this one. Activation, this one is the bar. What I call as activation bar. That's mean for this particular, because this is an object. So for this particular object, that's mean in this process, this is where they are working. It's not working, where they are active. active. Yeah, active. That's mean they have something to either a process or a message that they will send. So that's mean if in this bar they are active or they're processing some function maybe or some message, that's yeah, this is how it shows if the object is active or not. But if you see here, this is the this is the line. That means they are inactive. That means they are not processing or they're not receiving or returning any message. Same goes to this one. That means they are active process in this part, but inactive in this process. Same goes to this part. They're only active on this for payment. They are only active on this part. This one actually the diagram is quite simple. We will see the overall or the view of this sequence diagram. Actually, this is the okay. I know this diagram is quite hard because me too take time to understand this part, but diagram you have one, two, three object class here, and you can see, like I said, this is the message. Get name is the message from this actor. We have an actor here. This is an actor, so the first process done by this actor is to get name. So this is the first process or the first message in this particular sequence diagram. And then after they get the first name, they have this second process with list campaign. So this actor, this campaign manager want the list of campaign by sending a message to a client. If the on name is sequence from the and actually actually this like if you guys know already. Which part? Hmm. Let me explain again. So yeah, okay. This is your overall view of your sequence diagram. So like I said, the time or the process, this is should be no, this is the first process of your activity diagram. That's mean this actor requests something from this object, which is the get name, and then the next process is this one. So if you go, we skip to this part. If you go see down here, this should be the last process for this first part again. First part in this diagram or this one or the diagram. Okay, so the diagram. So yeah, like I said, this is your overall view of the sequence diagram, but you need to have actually, if you refer, maybe you need to have this enclosed frame. This is what we call as a frame. So for this, uh, what I noticed for this, like, from my reading, this diagram is actually first you need to enclose with a frame, and then this is important too, frame level. So frame level is actually the name of the use case diagram. Yeah, the name of the specific use case. Okay, so okay, so like I said, the timeline or the lifeline. No, no, no. The process, this process is actually shows an interaction or shows the, yeah, interaction between this actor, this object and object. So this diagram, it shows what is the process or message between these four entity here. It can be class or object, and it can include an actor too. So like I said, get name is the first message, or it can be message, or it can be any process. So get name is the first message sent to this client. So this is the first process. And then as you go down to the bottom of your diagram, it is the next sequence. It is in sequence from the top to the bottom. So this is the first and this is the last process of your diagram. So let me explain. So the first process is to get name from this actor to this object. So the campaign manager want to get name from this client. And then this is the, like I said, activation bar. So this is where this object is active or doing or processing something. So here they are, this is an activation bar. And then the next process is list campaign. This actor requests to list to get list campaign from a client. So this is a loop. This is a loop or a process done between this client and campaign. So here, this is an activation bar. That means this client or this object is processing something or active. Then they send this message. This message to this object campaign. This is the message. Yeah, they return. Oh no, this is not a return message. They're sending some message. So again, after this process, they are this process from actor to campaign. So they want to request all these advert, and then this is the process. Same goes with this one. Actually, for different process in a rectangle, in this rectangle, yeah, in this rectangle shape, actually, it can be different process. It can be loop, it can be break. There are a few which we will see later, but this is one of the process for this part. And then this is a process again, and then this is the last process on this diagram. So I know this is hard. So I already found, I think this video is around 8 minutes. So I give you guys until I also finish the video. So you guys can watch this first before we move on to our, you guys can watch this one first before we move on to our, to the next part. Okay.
Hi, my name is Angie, and I'll be teaching you about UML sequence diagrams. We'll start by explaining what a sequence diagram is and what it's used for, and then we'll create an example of our own. In this tutorial, we assume you have a basic understanding of UML. If you don't, click the link in the corner to watch our other UML videos and learn more. Sequence diagrams are a type of UML diagram that show how objects in a system or classes within code interact with each other. Particularly, these diagrams show interactions in the order they take place. In other words, they show the sequence of events. They're primarily used by developers and business professionals to document processes or understand the requirements of a new program. Now, before we get started, let's talk about how we're going to make our example. You could draw a sequence diagram with a pen and paper, but a diagramming application is going to make things much easier. Today, I'm using the diagramming software Lucidchart. If you'd like to follow along, click the link in the corner to access Lucidchart's website, enter your email address, and you'll have a free Lucidchart account in just a few seconds. It's easy to use, and you can follow along with me as we build a sequence diagram. First, we need a topic. For our example, let's diagram the interaction that happens at an ATM. The first step is to think of the parts that make up whatever your topic is. If you're diagramming a system, that would mean all the parts of that system. If you're diagramming code, that would mean all of the classes that make up the program. So in our case, what are the parts involved in an ATM transaction? A person goes to an ATM to get money, the ATM communicates with a bank server, and that person's bank account is then accessed. The ATM, bank server, and bank account are all part of the ATM system. These three items are our objects. The person, on the other hand, is external to the system. Therefore, they're an actor. Actors are always outside the scope of the system. In a sequence diagram, actors are represented by stick figures, and objects are represented by rectangles. So first we'll drag out an actor and place him here on the left. This represents the person trying to get money. Then we'll add our objects alongside it. We'll start by naming this object ATM, because the person first interacts with the ATM. Then bank server. And finally, bank account. You want the objects to be placed in sequential order from left to right. Next, we'll need to add lifelines. Lifelines are the vertical dashed lines that show the existence of an object or actor over time. Moving down the lifeline means that more time is passing. So we'll drag out a lifeline for the actor and for each of our objects. Now that we have our base chart laid out, we can start to diagram the interaction between our actor and our objects. To start, think of all the steps that happen when you go to get cash at an ATM. The first thing you'll need to do when you get to an ATM is insert your card. That will be our first message. Messages show the information being sent between objects. Sequence diagrams show the order of interactions or sequences, and they do this by moving down the lifeline with each message. So we'll start with the first one at the top. Drag out a line that connects the actor lifeline to the ATM lifeline. Now give it a label, insert card. Next, the ATM checks with the bank server to make sure it's a valid card. We'll drag out a line and place it between ATM and bank server, just below the previous message line. We'll label this one Verify Card. The server verifies the card and sends a message back to the ATM. When an object sends a message back, this is called a return or reply message, and they're always represented by a dashed line. Return lines often move from right to left, but that isn't always the case, as we'll see in a minute. So we'll drag out another line and connect it from the server lifeline to the ATM lifeline. We also need to change the line from solid to dashed. Again, the dashed line represents a return message, or a message from the receiving object back to the requesting object. We'll label this message as Card OK. After the card has been validated, the ATM will ask for a PIN. So we'll draw a line from the ATM to the actor and label it Request PIN. Because this message isn't replying to an earlier message and is requesting information rather than responding, this message is not a reply message and will be denoted by a solid line. So what happens when the card is invalid, like when an inserted card is expired? This is when an alternative frame is used. An alternative frame symbolizes a choice between two or more message sequences. These choices are usually mutually exclusive. So in this case, the conditions are if the card is valid or if it's not. We'll drag out one of these boxes and place it around the two messages we just created. The upper portion of the box will be labeled if card is valid, and the lower portion will say else. This says that if the card is valid, tell the ATM and the ATM will request a PIN. If the card is not valid, the server will tell the ATM and the ATM will eject the card. We'll make two more messages that show the alternate interaction, labeling them card invalid and eject card. After the ATM has determined the card to be valid and requested a PIN, the user will input their PIN. Since the ATM requested the PIN, and this is the user's response to that request, this message will be a return message. So we'll make a dashed line from the actor to the ATM and label it PIN entered. The ATM will then ask the server if the PIN is correct. We'll draw a line to represent that interaction and label it Verify PIN. Now we have the same situation as before, where we'll need to use an alternative frame. First, we'll create what happens if the PIN is valid. The server will tell the ATM the PIN is valid, and the ATM will ask the user how much cash they want to withdraw. So we'll drag out our alternative frame and place it around the two new messages, labeling the top portion if PIN is valid. Next, we'll add the alternative messages. The server will tell the ATM the PIN is invalid and the ATM will eject the card. We'll continue to map out the rest of the interaction by creating messages and return messages until the transaction is complete and the actor has received their money. The user will input an amount and the ATM will start a transaction with the server. The server then asks the bank account if there are sufficient funds to cover the transaction. If funds are sufficient, the server will withdraw the amount and tell the ATM to dispense the cash. If the funds are not sufficient, the transaction will be unsuccessful. Finally, the card will be ejected after the cash is dispensed or the transaction was canceled. With our interaction complete, now we can add activation boxes. Activation boxes show when and how long an object is performing a process. This shows us at a glance when objects are active and when they are idle. So we'll drag one out, place it on the ATM lifeline, and fit the box around the first and last message on the lifeline. We'll do the same for bank server and bank account. Since, as we discussed before, actors are external objects, they don't need an activation box. Now we can easily see that bank account is much less active than the rest of the objects in this sequence. While this example is fairly simple, sequence diagrams can get even more complex. For example, if you're diagramming code, the objects might be labeled as the names of classes, and the messages might be the methods and functions used in the code. It all depends on what you need to diagram and how complex you need it to be. Thanks for watching this tutorial on sequence diagrams. Please subscribe to our channel to watch more helpful tutorials. Leave a comment if you have any thoughts or questions. And lastly, click on the link to create a free Lucidchart account and start making your own sequence. Sorry.
Do it.
Do it now. Leave it right here.
Leave it.
So have you guys watched the video? Actually, if you guys notice in the video, it's in the short video, they use this frame here as alternative, right? Just now, if I'm not mistaken, alternative for if-else function. So actually, this one we will see later, because in our lecture note here we are using loop for looping, yeah, loop function. But in the video just now they are using alternative. So this box actually what we call, or this function here actually what we call as interaction operator. This is an interaction. This is an interaction of it operator. So in the video just now, it's an alternative. That's mean alternative for if else. If you watch the video, so it was if else function alternative. So in this lecture note, we are using loop, but we will see later to what is or what are the operator here. So I think from the video you guys watched just now, you guys can get the, you guys I mean, you guys get the overall, I mean, you guys understand what is sequence diagram. Okay, because like I said, this point here or the explanation here is literally on the diagram. What is the function? So here is on this page, iteration is represented by combined fragment rectangle with the interaction operator loop. So this one, what I said just now, rectangle is this part. This part. So the interaction is represented by combined fragment with the interaction loop. So we are using loop for this example. So this is just the explanation from the loop function just now. So the loop combined fragment only execute if the guard condition in the interaction constraint evaluate as true. That means there are conditions that they need to check in order to execute this function. And object creation is shown with the construction arrow dash going to the object symbol for the advert lifeline. Advert lifeline. This one. Okay. So this one for the previous patch or previous diagram. So a synchronous message or procedural message is shown with a full arrowhead cause the invoking operation is suspend execution after because operation. So a synchronous message is actually, wait, let me check. A synchronous message is actually a, okay, synchronous message is actually a procedural call that, wait, let me confirm first. Synchronous message. Hmm. What is the difference? 1 minute, guys. Message need to respond before the interaction. Message before the interaction. Message before interaction. Blocking message. Written message. This is written message. This is message. This is, I think, no. This is a process. Or invoking operation to suspend. Blocking message. 1 minute, guys. I'm confused with the procedure call is shown with a full of red cost invoking operation to suspend. Hmm. Invoking operation to suspend execution. Oh, okay. So actually, before we go to this, we need to understand, or we need to see what is the message. I mean, the message can be in the use, no, the notation of the two, which is this one. This is a message. This is a message, the original message sent by the first lifeline or first object here. So this is the this is the message, and this is the return message. This is, yeah, this is what we call this dash line is known as return message. So this is an actually a function or a message which we need to have, or this is a process of message that they need to have a written message. They need to have a response before they can send any interaction. The interaction, like I said, how the object is interact with each other is by using the message. So they need to have a message, or they need to have a response before they can proceed, or before they can continue with the interaction. So this is actually a process. It's not a process. It's a message. It's a type of message. Yeah, it's a type of message. So that is a synchronous message. So synchronous message need a response, like I read here, need a response before interaction. So they need something like trigger the message before they can send the message. So that is synchronous message or procedural call. They need something to trigger them before they can send the message, or before they can proceed with the message. So that is synchronous message. But in the diagram, like I said just now, in the diagram, basically what we see is only two type or two type of error. This one is the error. This one is the message. This is message. So this is the message sent, and if you see this notation is a return message, or here it's set as a message reply or known as return message. So here, event occurrence message send event start execution. This is actually a process. This diagram or sequence diagram is showing the interaction name. So the first process is this one. From lifeline A, from object A to object B, they are sending a message for event occurrence. So this is a message. So this bar here, what we call as an activation bar. Like I said, activation bar, and as you guys already watched in the video, activation bar shows if the object here is activate or an in idle mode. So they are active here. That means they're processing something or they're doing something. Either they want to process or they want to return any message to the previous object. So they are processing, or yeah, they are executing something, and then this they return the message to this one. This object return the message to this one. If you guys read this lecture note for the first time, it takes time to, because you need to understand the process, or you need to understand because there are many explanations. So we tend to get confused. But like I said, if you guys know already what is the function of each of the notation, you guys can easily understand the process of the diagram. Because sequence diagram is only or basically purpose used to show the interaction in order of time. So this one is only one process, which is this object send this object a message, and then this object is returning this object message too. Okay, so most of use cases imply at least one boundary object that manage the dialogue between the actor and the system in the next sequence diagram. This one we'll check in the next sequence diagram at advert UI. So the control object is represented by lifeline. In this message, or in this message, the overall object communication. So the problem domain, or what we know as entity class, represent the layer that will map to the classes. Okay, this one is three tier design. But what is three tier design? Actually, three tier design is an architecture. Three tier design is an architecture that shows or architecture that organize the application. So basically there are three functions, which is we will see later. So three-tier design, what you need to know is it is an architecture that organize our application. So the introduction of boundary and control stereotype into interaction diagram is surely making an early decision to the three-tier architecture. So here they didn't explain what is three-tier design, but three-tier design, like I said, it is an architecture that organize our application. So this is the basic layer or the basic tier of our three-tier design. Basically, we have it have three layer, which is presentation and business logic, or what we call as UI, user interface, the front end, and the database, where the data will be processed in our application. So the presentation layer, control layer, and data access layer. So presentation, UI, or the user interface, and where the data will be processed. Okay, so actually the basic, or how can we, because again we are seeing this diagram. So basically three-tier design is actually to show how our organized, or how our application is organized. That's mean if you can relate, yeah, if you can relate the three, or yeah, the three tier with the sequence diagram, because if you go back to the three tier, we have presentation, business logic, or what we call as the UI, the front end, and the DB. So in this diagram, we can know what is the process, that should bind or should, yeah, bind to the tire. For campaign manager, as you can see, this is a process, or okay, let me explain this diagram first. But I think most of you know already how to read this diagram. So this is the, like I said, just now, this is the the name of this diagram, or known as frame level. This is actually more or less like our use case. This is the name of the use case. So add a new advert to a campaign. So this is a process to add new advert to our campaign. So this is the object involved in this process to add new advert by this actor, by this manager. So here, this is the sequence of the diagram. So the first one, this actor send a message to this object. So this object will process. As you can see, this is an activation bar. That means this object is active using, or this object is active in this part of the process. And then they're processing something, and then again this actor send a message to this object. So this is a box where they have a process, which is, like I said, the interaction operator. But interaction operator is not only limited to loop, or just now in the video, I forgot what the activation operator they use, but there are few operation operator actually. So here is the process. That's mean this process combine fragment loop. That's mean it between these two object, and then this message again, and this process again, and this message, and this return message to this uh, object. So three-tier design is actually how this overall the sequence diagram shows the, or what is the architecture that organize our application. That's mean um, presentation and business logic. Right. Presentation. Actually, this is just the logic, or this is just the overall view. That's mean in our sequence diagram, there are these three layers. That means some part will bind to some part will bind to the sum of the process here. For example, let me give you an example. This is not complete instruction. For example, business logic. Where's the return message? Where the data will process, advert, new advert, add new advert. So, okay. So, like I said, the three-tier message, the three-tier architecture is actually in the tier, there are some part that bind to the some part of this diagram. For example, the database, the last part where the data access layer, where the data will be stored, or where the data will be processed, but depends on the process actually. But for this one, because we are adding a new advert or campaign, so in the database, this is the database layer, database database layer, right? Data access layer. That means they will store, or they will add this new advert to the database. So because this example is not really explain how this three layer, three layer, or three tier should bind with, or how it is related with the sequence diagram. But if you understand, like I said, if you understand the three tier architecture and how to connect them with this diagram, then you should know which tier or which layer should bind to which process in your activity diagram. Okay, so in three-tier architecture is not, I don't think that is hard to understand because the name represent the meaning. So I think that's quite easy, but the problem is in this lecture note they didn't show what is the or how to bind the tire with your diagram. But as long as you know the notation and as long as you know what is the function of the tire architecture, then it's okay already. I think yes. And then we move to the same sequence diagram, which is add a new advert to a campaign. So here is our boundary line and is our control line. So you need to know, I think I already mentioned, already explained here. The boundary and the control, the boundary and the control lifeline. Yeah, the boundary and the control lifeline. So here the this one is not complex, but they are using for object for interaction for interaction with the actor. So actually this is not complicated. As you can see, there are only three. They are using the same logic. What do we call this? Oh, they're using the same interaction operator, which is loop. So they are using or they're performing the same function, which is looping. Yeah. So this architecture diagram is actually mm, not complex. It's quite big because they're using the interaction between four object and one actor. So as we go down the process, this is the last output. Yeah, the last output or the last result from this sequence diagram, which is they manage to add a new advert to the campaign. You guys understand or not? So here, this is again the sequence diagram. So I want to ask based on this one diagram, what is the purpose or what is the interaction of this sequence diagram? No L. What is this sequence diagram? Uh, what is the use of this sequence diagram? This one. What is the function or what is the use of this sequence diagram? Yes, like I say, you can check on this name here. This one is delete advert. This one is to add a new advert to a campaign. So add a new advert to a campaign. Like I said, this one is the output or this one is the last process where they manage to add new advert. So this one is to delete advert. So like I said, this one is your object, is your process, your activation bar, and your message. And this is a message to delete an advert from this object to this object. So this object trying to send a message to advert to delete the advert. So this is new for you guys. This is object destruction. So what is object destruction? So object destruction is actually a process or it's a process like to terminate. Yeah, to terminate. It's like a, yeah, terminate should be. That means when we no longer need it because yeah, when we no longer needed that object or that class, so we do the object destruction. So to relate back with this sequence diagram, so here we want to delete advert. So this is a message sent to delete the advert, and this is a notation that state or that we want to tell we no longer needed this part. Yeah, we no longer needed this part. So this is a notation to show the object destruction. This one is mostly used if you want to delete something, delete function or anything. if we want to delete the object of the class, so we can use this object destruction. That means it's no longer needed. So this is the notation of object destruction. So Ian, what is the function of this sequence diagram? Ian, what is the function of this sequence diagram? What they want to do? Yes, to check the campaign budget. So, Jeremiah, what is the object in this sequence diagram? Jeremiah, what is the object in this sequence diagram? Oh, client campaign advert. Yeah, client campaign and advert. Hmm. Then, what is the longest or yeah, which object has the longest activation? I mean that the active longer than other longer. Yeah, that mean in this between these three objects, which object that process or active more than other object? Rachel, Rachel, which hmm? Hmm? I mean from the I already explained. Oh. Hmm, before I explain, Alvin, between these three objects, which object do you think has the longest processing? Oh, which object is the have the longer activation time? Activation. I mean the active other than other object. You guys understand or not? I mean, how to know if the campaign? How to know? We have an answer. This is correct. But how to know actually if the object is active or not by check on this bar? This is the activation bar. So this activation bar show is if the object is in idle or active. Active, that means they are processing something, or it can be any process, or it can be any message that they're processing. So how to know if they are active or not is by checking, or yeah, by this bar. So my question just now, between these three objects, which object has the longest activation time? So it is campaign, because as you can see, the campaign here is processed most, it's not most of the time, but it processed more than other object. So this one is the most, I'm not sure what the term, but it processed more than other object. So this is the one with the less process or activation time, activation period. This one. So, okay, yeah, that's all my question. But here in this page, there's a reflexive message. So reflexive message is actually a message that it sent to itself. So for example here, campaign, campaign trying to send a message. Get, the message is get overheads. So this is a message. This is a message sent to itself. So reflexive message is a message that sent to itself. That means I send message to myself. So I process the message on my own. So that is reflexive message. So here that means this object send message to itself. Campaign send message to campaign. Okay, understood? I have a link here, but I forgot what is this link for? So guys, can we have a 5 minute break? We will continue at 11:21. Okay. Actually, I want to check this one. So hi guys, can we proceed? Can we continue? Okay. So before I break this now, I send you guys a link. This is a link actually. I this is my from my reading. This is the link I think that will help you guys to understand the notation of the sequence diagram, because in our lecture note they didn't really like they combine everything in a point form, so it's quite confusing. So you can check this link. Okay, I think this is very useful. Okay, so let's continue from where we stop just now. So before we stop just now, I explained about reflexive message. So let me recap again. So reflexive message is a message that we send or that or the object sent to itself. So reflexive message is object that we send to ourselves. Okay, so let's continue from that part just now. So let's move to focus of control or FOC. Yeah, FOC, focus of control. So focus of control is actually to show the period of time to show in the process. We'll see this diagram later. So FOC or focus of control is actually to show the like in the activation bar. Never mind. I will show in this diagram later. So indicate time during an activation, show when processing is taking place within the object. That's mean focus of control is to show the period of the time during which it's like which period in the process. Never mind. So indicates time during an activation when processing is taking place within that object. And then parts of an activation that are not within the focus of control represent periods when, for example, an operation is waiting for a return from another object. That's mean if it is not the FOC, that's mean that part of the object or that part of the process is waiting something. It is active, but it is waiting for something. So that is not FOC. It's not focus of control. And then may be shown by shading those parts of the activation rectangle that correspond to active processing by an operation. So this point we will see in this diagram. So FOC actually, if you notice here, this is where the shade, this part with shading, right? You're using, yeah. For example, here this is the activation bar. So this activation bar is shaded. That means this is the focus of control. That means in this area, in this particular activation bar, they are processing or they are doing something. Okay, let's look at another this activation bar. So in this activation bar, if you guys see, they are in the same activation bar, but as you can see, they are black and white or shading part. So this shading part, what we call FOC, focus of control. That means they are doing something. They are active and processing something within this process. Okay. Compare is not compare. And then referring to this one, they are active, but they are waiting for some process or some maybe some written message from other object for them. Then only can they can process. So this is an idle, like I said, activation bar is to show if your object is in idle or in active mode. This in this part, this object is in active mode, but in this process itself, that's mean in the black, the shaded part, they are doing something while in this in the same activation bar which is not shaded. That's mean they're waiting for some process or some message to be written in order for them to process with their next action. So that is FOC or focus of control. Okay, so this diagram is explain these 3 points just now from this previous diagram. So what you guys need to know is only what is FOC. That means in one in the same activation bar, FOC can occur by FOC is occur when your object is processing something and it is active, but it is not processing if it is waiting for other process or other message to be returned to them. So that is actually FOC. That is what explained from the previous page. Okay, so here, like I said just now, shading showing the focus of control. That means this process or this activation bar is fully processing something. They are doing, yeah, they are doing something, processing something. So this is focus of control. Same goes to this one. They are active and fully doing something, processing something. But compared to this one, they are active, but they are they have some not they only have some part which is FOC. So the shaded part is the FOC. Here reply with the return valuation. Mm, as you can see here on this activation bar, here, here on this activation bar, after this process, after this FOC down here, the black one, referring to the black one, after they process, after they focus of control, they return message to this actor. So like the from the previous patch, you guys should know this one already. This is a return message. This is a return message. So this dash dot line with an arrow is a return message. Okay. Don't confuse the return message with a message. Message is with a solid line. Return message with this uh dash dot line. Yeah. So the reply with the return valuation. Okay, so do you guys understand what is FOC? I think yes, right? Because it's quite easy. You just need to focus on the bar and then you just need to look for the shaded shed. For your assignment, we also need to shed. For your assignment, it's referred to your process. Of course, you need to apply this, but it will refer to your process. If you have that activation bar and your in that particular activation bar, that bar have some FOC, then you need to shed. Okay, Kelvin Shark. Kelvin Shark, okay. So that is FOC. Mm, yeah, I think, never mind. So sequence diagram, reply message. Okay, reply message. I will touch this part later, but before we go to this point, so reply message is actually this one. A reply message is a return message, which we already see from the previous page. So reply message is this one, a return message. This is a return message, okay? A return message. Do not get confused or don't get mixed with the message. This is a message. As you can see, the arrow, the line of this arrow is different. This is a solid line. This is a dash line. So this is a reply message here. Okay. So a reply message return the control to the object that originate the message that begin the activation. So that means the reply message will return the message to the object that trigger them. So reply message are shown with a dash arrow. So this is a reply message that with a dash arrow, but it is optional to show them at all since it can be assumed that the control is returned to the originating object at the end of the activation. So here, from this point here, from this second point here, it is stated that it is an optional to show them. But why it is says that it is an optional to return this message? Because we assume they get back what they want. If you go to it, see, it can be assumed that the control is returned to the originating object at the end of the activation. But for your assignment, I don't want any assumption in order for me not to uh, in your assignment, I don't want any assumption, so you need to write your return message. Don't assume me. Don't assume. Don't make an assumption that I will understand your diagram. So in your assignment, if you have written message, and if you, of course, you will have a message. If you have the written message, of course, you will have, you need to draw or you need to write them with the message, the arrow with the message here. Okay, don't make any assumption. You need to return your message here with the correct notation or correct line. Okay, okay. So here, this is another sequence diagram to check campaign budget. So as you can see, this check campaign budget, they have this object, they have message, and they have this is what we call as an interaction operator. Like I said, so I is equal to 1, I less than campaign, count I plus plus. Okay, so um, I won't touch what is in this, what is the condition for this. You guys can read later because this is not programming, but this is the condition where they initialize I with 1, and then this is the condition which is I less than or equal to the campaign count, and the iteration is I plus plus. I won't explain this part. But in this loop, this is what we call as interaction operator. So interaction constraints refer to the variable used in object selector notation. So they need to check the condition or in order, no, I won't say condition because that's more to programming, but they need to check the, yes, the condition. So they need to check the condition between these two objects in order to execute. As you can see here, there is an activation bar, but here in the activation bar, they didn't start the focus of control. They just they just show if there are some process here to get campaign detail here, and the process is this. This is the process, the looping function. You guys should know what is looping function. So this is a looping function. So they will keep processing until they want, until they exit the loop. Okay. And then next, this is another looping function. They will check this, they will process this function until they exit this looping function. And then they have a message here, like I said just now. What is this message? Daniel, what is this message I mentioned just now? Tan Sunyap Daniel, what is this message? The message that send message to itself. Tan Sunyap Daniel, what is this? Ah, Kelvin Sharp, what is this message? I mean, this is a message, but what is the name of the message if I send message to myself? Yes, reflexive message. So this is reflexive message. Okay, never mind, Daniel. So this is reflexive message. Okay. I think, yeah. And then we have the same diagram actually from the previous one, check campaign budget. But here, let me just highlight what is the difference between the previous page is here, interaction operator with parameter. Like I said, in this box, it is something that we call as interaction operator. But if you check this interaction operator here, they didn't state anything. They just state here, they just state this is a loop function. This is, they're using loop as an operator. But if you check this page, they have the parameter 1, 2 more. So this is the parameter that they need to check. Okay. And then This is ALT is actually for alternate. This is another operator in interaction operator. Alternate, yeah, alternate. So this is, oh, this one is the alternate. I remember this one is from the video. I think they're using alternate just now. So this is the if else function. That means they have two. I assume you guys know what if else function. They have two, not two process. Yeah, they're using if else here. So this is an alternate function. So it can be this. So if the process is not this one, it will go to this one. So this one is alternate function like shows in the video, and it is an interaction operator. So the interaction operator here is alternate. The the interaction operator here is loop. You just refer to this one. There are a few. I think we will see later. So what you need to know, this is what we call as interaction operator. So this one is an alternate interaction operator. Okay, so since I cannot upload answer to you guys, like I already mentioned in our previous class, if I'm not mistaken. So let's do this now. Ivan, Ivan, what is the first answer? Is this true or false? Object communicates by sending message. Is this true or false? This is, I think, in the third page of what earlier in our chapter, I messaged that how the message, oh, how the object communicate with each other. So guys, is this correct or false? Object communicate by sending message. Yes, true. An interaction defines the message passing between the second one. B is true or false? B is true too. So vertical dimension shows time. Is it true or false? Shows time in order of, yes, true. Message are shown by dot vertical. Is this true or correct?
False.
True? False. Why? Because don't get confused, like I said. The question asks if the message is represented by the dash line, right? A message is represented by a solid line. This is a message. Don't get confused with a written message. So the answer is false because this is a written message. This is a message. Okay, so message are shown by a dot vertical arrow. This is false. Reply message is just arrow. This one is the last one, E, reply message, true. Okay. This is, they just basically ask you the notation or the function of the sequence diagram. And then next we move to the interaction operator. This one, the one that I said here, interaction operator. It have a few interaction operator. So the first one, alternate. This one, the one I think you guys should know already. This one is more or less like if else function. So you can read here alternate function, alternative represent alternative behavior. That means if not this one, it should go to this one. If else function, its choice of behavior being shown in a separate operand. The operand whose interaction constraint is evaluated as true or executed. That means they need to check the condition. Yeah, they need to check the condition in order for them to proceed which behavior or which part they should process. So alternative, it's alternative, right? Or alternate. But I think it's between alternative or alternate. Yeah, but by the way, this is if else function for alternative function, interaction operator. Then the second one, this is optional. Option describes single choice operand that will only execute if its interaction constraints evaluates as true. Wait, reply message true. Oh, okay, I remember. So this one that I get from my reading, you guys can check this link. So this one actually, if you go into that link, so this is the operator actually, that the operator they use. So this one is optional operator, option operator, option operator, which means they need to be executed only if the interaction constraints evaluate as true. Okay, this one. Actually, for each of the interaction operator here, that's why this page has 90 plus plus. Actually, the interaction operator, what you need to know is, I won't expect you guys to memorize each of the alternate operator, but what I want you guys to know is uh, how to use them in your diagram if you need that interaction operator. Okay. No, what I'm trying to say is, of course, you need to understand how to use them, but I don't expect you guys to memorize each and every single of them, but you need to know when do you need the interaction operator. For example, here in this process, do you think that you need the interaction operator or not? If yes, then you need to find what is the suitable operator that needed for your process. This one is option, this one is break. So break is indicate, we just refer to this. So break function or break operator is to use to, this one is, I think is nested. No. So break indicate that the combined fragment is performed instead of the remainder of the enclosing interaction fragment. Okay, this is for the break function. And then this is a loop. Loop is loop is should I explain? Loop is like a processing, a repetition. Yeah, repetition. So loop is used to indicate an operand that is repeated. So you need to check. I mean, the process will check. This is the condition. They will check how many times they need to repeat or how many times they need to loop. So here, as you can see, the loop is expected to execute minimum 5 and not more than 10 times. So this one is the parameter like this now. So this is the condition. So they will loop between this range. At least 5 and less than 10 times. So the explanation here, they just said that you will repeat or you need to do the looping to fulfill the condition, and it will exit it will exit the loop until it no longer meet the condition here of the loop is no longer true. Yeah, this is a loop operator. And then this one is a parallel. You just want to say loop for looping. Actually, for looping kan, if you don't put, I want to ask you guys, if you don't put condition to your looping, what is the name or what is the term of that? Um, I don't know how to say it. Because in a programming, you need to, okay, Kelvin Shark, you want to ask if you don't put the number, you can write something like this, but you need to be very careful when you're writing looping function. You need to set somewhere your condition, because if not, then it will be the infinity looping. That means your process will be infinite. You will keep repeating your process. If you do not want to write your process here, this is alternate loop. If you don't want to state your condition here, you need to state somewhere outside your, just to explain or just to show that they are conditioned, because If you're using looping, you need to be very careful with the syntax of the looping. Writing looping, you need to set your condition. If not, there what we call as an infinite loop. That's mean because you guys, I expect you guys doing programming, right? So if I read your looping and if you guys using looping as an operator and you guys did not put any condition, any requirement, or where the looping should stop, I will assume it as an infinite loop. That means the process will only occur in this one and this process. No stopping, no stopping point. Yeah, no stopping point. So if you don't want to write number, you need to indicate somewhere. Okay, loop. Okay, loop. Okay, siapa ni? Shark. You need to indicate somewhere. Mm, yes, because that's the logic of looping. If not, it will be infinite looping. If your lecturer, I don't know, maybe if your lecturer do not do programming, maybe you guys can, maybe she will let that part slide. But since I'm doing programming, so I need to apply that logic there for looping. Okay, so that one for looping, just set the condition for it to exist, to exit the looping function. Okay, and then second is the parallel operator. So parallel operator is to merge the keyword to this parallel operator is to merge the function. That's mean, as you can see here, they are sending three message, which is search Google, search Bing, or search us. Maybe us is one of the search engine. I'm not sure. So this is the search engine. So they want to send a message. That means they search together and then they merge it in one sequence. So yeah, that is parallel. Parallel operator. That means they're doing this together. Possibly by parallel. Parallel is like, what's the term? Concurrent. Concurrent, yeah, together. And then next is sequence and strict. Sequence, the first one is sequence and then the strict. So what is the difference? So for weak sequence, they need to, as you can see here, weak sequence result in the ordering of each operand being maintained, but even occurrence from different operands and different lifeline may occur in order. So this one is for sequence, but for strict, it is imposes a strict sequence on execution of the operands, but does not apply nested fragment. Nested. Search Google. Okay, here is an example for sequence. So search Google possibly parallel with Bing and Yahoo, but search Bing before Yahoo. So search Google possibly parallel. So here, as you can see, search Bing before Yahoo. Okay, so as you can see, the explanation here, search Google possibly parallel with these two, but search Bing before Yahoo. That means they are processing this process concurrently together, but this process, because the logic of the concept of the sequence diagram is to show the process in order. This process is together, but I mean they are together, but yeah, they are parallel together, concurrent, but this process is the first process before this part, before the second part. Okay, and then strict sequential order. Search Google, Bing, and Yahoo in the strict sequential order. So strict sequential imposes a strict sequence on execution of the operand, but does not apply to the nested fragment. So guys, what is nested? What is nested? Anyone know what is nested? No. So nested function or nested is actually hmm, nested. Yeah, nested is actually function. Yeah, nested is actually a function within a function that is nested. So it's inside. So a function within a function. So it is inside. So if they ask you again programming, I don't want to talk about programming, but yeah, for nested loop, that's mean a loop within a loop function. Same goes to this one. So if they said the nested if, that means if inside if function. So this one, if you refer to this nested fragment, that means this process within another process. Okay. Okay. And then is negative describe. But how many do we have? Oh, okay. Ignore critical. So here we have negative operator. So negative describe an operand that is invalid. So they need to return a message to state that this is invalid. Okay. Negative operator is actually, for example here, we want to log in. From this object, we send, object A send a process to send a message to object B to indicate that they want to log in. But this box here return a message that this process or this message that sent is invalid. It can be due to any reason, maybe due to authentication, or here on this example, they're using timeout as a negative return result. Okay. Should we receive back timeout message is misspelled. Timeout maybe they, I'm not sure what is the reason of a timeout. Maybe because inactive inactive patch. So that's why they return this message. So this is basically the negative operator to state that the operator or the message we send is invalid. So we need to return, we need to respond to them by saying that this is the reason, timeout. So that is negative operator. And then next we have critical. So here this is nested, this function, this critical within this parallel function. This is the definition for this context. That's mean operator within an operator. So critical between the parallel. So this is nested. Okay. So critical is imposed on the operand that none of its event occurrence on the lifetime in the region can be interleaved. So interleave, I already checked the definition for interleave. Interleave is actually blank, empty. So yeah, so interleave is blank or empty. So here they have parallel process, which is add and remove. And then add or remove could be called in parallel. But each of one should run as a critical region. So you need to, in order to fulfill this operator, we need to check on the inside part first. So since they're using critical, so we need to check what is the explanation or what is the logic for critical. Okay, and then this is ignore. Ignore get set. So for ignore operator, from the terms or from the word ignore indicate the message type specified as parameter that should be ignored in the interaction. So here, if we have this function to ignore get and set, they will ignore the function. So ignore get and set message, if any. So we need to declare here what we want to ignore, what message or what function we want to ignore. So here they didn't mention because this is add and remove message. So they won't ignore this part. Instead, they will ignore whatever we declare inside this part, inside this declaration. So they will ignore the get and set message if they have any. So this one is consider okay. This one is considers that which message should be considered in the interaction. So different with the ignore just now. Again, you need to use the correct operator. If not, it will obviously it will be wrong. So consider, so they need to consider this message and add and remove message or function. Ignore any other. That means this one is contradict with the ignore operator just now. And then next we have a z, a z, yeah. A z is to indicate that the sequence of messaging in the operand is the only valid continuation. So commit message should occur at this point following the evaluation of state invariant. So a z is just the sequence of messaging. Okay. This one, again, like I said, I won't provide answer, but instead, you guys, I mean, this one actually deposit cash for the cash deposit machine in bank. I think this one is, you guys can check with the link. Yeah, coincidentally, this is the one that I sent you guys the link. So you guys try to do this one, okay? You guys try to do this one later, and maybe in our tutorial or our next lecture, I will show you what is the sample answer for this one. Any question before we dismiss? No. So, okay, I think we can dismiss now. Thank you, guys.